In Java, there are actually 50 keywords. So this small exercise which we'll do is, right, we'll try to identify and list all the 50 keywords. There are 50 keywords in Java. So we should get that count of 50. And we can go slightly systematically, try to go systematically in terms of what kinds of things we are trying to do. Okay. 50 keywords. Yeah. So starting with, let's say the data types, the primitive types, all the primitive types they are keywords. So we have what? Byte, short, int, long, float, double, char, boolean. Okay. These are primitive types, and then we can use those keywords which are used for defining types. Okay, class is another keyword. Okay, another one. We have the return type, additional return type of void. Void is a keyword. Void. Okay, we define a class. So we have the keyword class. Then we have interface. Annotation of the keyword. Okay. Then some of those keywords, like we use it within the class definition anytime for the current object. Then we have got this super, this and super. What are the keywords?
Then control statements.
We'll come to statements, but before that, let's go for modifiers, right? And these are primitives. This is additional return type. This, up to this point, the things we define, keywords used for defining. We have, when you define interface and class, right? We have relationships, inheritance relationship, defined by, which are the keywords used there? Extends. Another one? Implements. Extends, implements, then. Okay. Now we can start with modifiers. Fine. We had seen modifiers yesterday. So access specifiers. Okay. So access specifiers like public, private, protected, volatile. Okay. Fine. modifiers for so this is access specifiers. Right? A modifier within the class static. Then two kinds of members, static and the non-static. Static is another. Okay. Then yeah. So static, non-static. Okay. We have modifiers for class. Let's start with let's see yesterday those modifiers.
Negative.
Let's start with the modifiers for class. First, let's look at class. What were the modifiers for a class? Other than saying public, private, protected. What were the other modifiers for a class? Class could be abstract.
Yes, sir.
Class could be final. Class could be abstract. Okay. Class could be final. Then what are the modifiers? What are the modifiers? For class, anything else was there? No, there was still one more. For a class, class. That's the. Yeah. We're trying to list all the keywords. There are 50 keywords. For class, one more. That's used for class and annotation. Annotation is not a keyword. Huh? It's only for method. Native is only for method. Not very rarely used. Related to the floating point.
FP.
Strict
Strict FP. Yes.
Okay. Then what else? So I think for class, okay. Now let's look at modifiers for methods. Let's start with methods. What are the modifiers? Anything which is missing for method? And all these are there. Yeah. Static also. Then
Synchronized.
we have synchronized. We have final.
Final आ गया इसमें.
Final is available. Native, I don't know you are mentioning native, so that's native. Volatile is not for method, it's only for variable. Yes. For methods, I think synchronized is the additional native addition. So final has already been used. Any other? No, yesterday's list takes the important. Right? Next, for variables. Yeah, we are mentioning volatile. Transient. Huh? Modifiers. Any other modifiers? There's one more modifier which is for methods. There's one more modifier for methods. That's from Java 8. It's a modifier for methods from Java 8. There's a keyword which is being there earlier also. It's a keyword which was there earlier, right? But it was not. It was used in a different place. It has been also used as a modifier for method in Java 8. It's used as a modifier for methods in an interface, not within the class.
Lambda.
Within interface, when you define a method, what's a modifier? From Java 8, we have additional thing called, you could have methods which are okay. It's not a new keyword from Java 8, right? But that's a keyword which was new. That keyword was used in switch case, right? So yeah, we'll come to statements. Are there any other modifiers which it's used in place? Modifiers. Huh? Huh? You have to go to 50. You have to there are 50 keywords. Right? And let me tell you, there are three things which are not keywords. They are letters. I'll put those three letters. There are three letters. Okay. True, false, and no. Right? Three letters. They are true and false. Okay, for the Boolean constants and null. These three are letters, so don't count them. There is 50 plus 3. Okay. 3 letters. 50 keywords, 3 letters.
So if we declare default in a method is default in
Interface.
what force?
So I think we missing one thing. New.
Yeah. New is a statement. It's not a modifier anymore. What we have listed so far, okay, we are trying to get, we are trying to list all 50, but yes, we are slightly grouping. And we are trying to group. This is all primitive types. This is a return type. These are the types we define: class, interface, enum. And within those class, interface, enum, we have this and super, which could be used. Okay, the relationships between the types, extends and implements, and then we have the access specifiers. Okay, everything could be static or non-static within a class. Then these are all modifiers we are trying to do, right? Yeah. 29 or 28 over.
So backend related one. Backend.
28. Oh yes, I forgot. Missed out. Should have listed it earlier, right? This was all about types. So there we have package and import. Okay. Then
Control statement.
okay, statements.
Yes.
Okay. This is 30, I think. 10 each. Now let's start with statements. Okay. So if
Else.
else
Switch.
switch
Yes.
case
Break.
break
Continue. While.
continue
While.
while do
For.
for
Knowledge.
okay, these are control flow, right? Yeah, control flow. Yeah. Then related to exceptions.
Yes. Throw.
Okay, now let's look at exception. So it will be throw. Okay, from declarative, right? There's a declarative. There's not actually a statement. A declaration could be throws the
Catch.
try catch
Final.
finally this new. We talk about new as a assert. Well, there's one keyword called assert also, which is related to exceptions. What else?
It is good in
No. Related to that.
Instance of.
Huh?
Instance of.
The operator instance of, that's one. Oh, we have the operators. Instance of.
Return.
Yes. Instance of. Okay. Then we have the return. Okay.
Then two more. One constant and two.
Constant. Oh. Constant and go to. Right, so we finished 50 keywords. Okay. Fine. Any of those keywords which you feel that we need to discuss?
So quality.
Okay. So let's mark out. No. Now let's try to mark out what keywords we may discuss further. Right?
Yes.
One is okay, assert. Right? This was okay, I didn't talk about it in core Java.
default for the
Volatile. Okay, you want to understand about the default for methods and default for methods in an interface. Okay, what else?
What about constant and link?
Constant unused. So nothing we have to talk about. And not used. Anything which you want should be revised or inserted. Strict FP we mentioned yesterday, right? So that's okay. Strict FP.
Also,
Instance also no. Static import. Oh. Yeah. So default, volatile, and the other thing is asset. Right? Volatile is something related to synchronize, what we explained earlier. And what we understand about synchronize. And so we want to discuss about what is default. The other is the volatile, and the third thing is asset. Okay, let's look at what is default first. Okay, default. Yeah. Okay. From Java 8, right? This is Java 8. Default and method comes from Java 8. So since Java 8, what has been done? We have multiple inheritance of types. We have multiple inheritance of types in Java by using interfaces. Okay. So that multiple inheritance of types remains as it is. Okay. What we didn't have in Java was multiple inheritance of state and behavior. What has been added here is multiple inheritance of behavior, but not of state. I'll explain what I mean by this. Interface would not have a state. No instance variables in interface. Right? Instance variables are not available in interface. Okay. So we have in interface. Let me start with what is the problem which was being faced here. Why we had something like default. Then I'll talk about this. Okay. Java always gives us backward compatibility. Then it has to maintain backward compatibility. And therefore, there was one difficulty which was happening with interfaces. Interfaces in the API, especially the interfaces which are there in the API. For example, you have an interface called list. Okay, you have this interface called list. List interface came in Java 1.2. Okay, and at that time, they didn't think that we should have a method called sort. Right? Sort is a method which would have been there in the list interface. Okay. Now, in 1.2 they have released list as an interface. There will be people who will be implementing this interface. When they implement this interface, they won't imagine that we should have a method called sort in their implementation. Right? They were only forced to have those specific limited set of methods. Now, later it is realized that it's better to have a method called sort. But can the sort method now be added in an interface? Which was the earlier definition of interface? Earlier definition of interface was, so you only have abstract methods. Interface means abstract methods and static constants, nothing else in interface. Okay. So how do we go about saying, oh, we want backward compatibility? And be able to upgrade your API for the interfaces. Okay. So what was done? So in Java 8, what was done was, we said, okay, in interface, you may have abstract methods as it was there, but if you want, you can always add a new method by declaring it as a default method. So we have a sort method, returns void, but there is a default. We are saying this is the default implementation, right? And here, with the sort method, may be some parameters. You write a implementation. So interface can have methods which have implementation. This is from Java 8. So Java 8 added two kinds of things in the interface. One was default method, and if default methods are there, what's the problem with static methods? So you can have static methods also. With implementation. Static methods are always with implementation. They are never abstract.
So default will also be written in our
interface. So in interface allows you to put, see, in interface by default methods are abstract. And therefore, if you are to write an implementation, put the keyword default.
So now it becomes abstract class. It's like
This
Interface
it
becomes
like an abstract class, but the difference is no state. There is no instance variable for it. Right? And there are multiple inheritance using types. For types using interfaces is still okay. We're not in when we don't have multiple inheritance of state. We're not getting instance variables from two places, but we are getting behavior. Implementations can come from multiple places.
So, in that case, in real life scenario, if I have a document class and I am like developing few more classes like invoice, challan, and etc. So, if I declare an interface document and there is an implementation like default void gets ID, I can write the entire
Implementation can be there, but you will not have instance variables.
Instance, but
then
return, it will have a return, right?
it will have, that's
It
what
will have return.
it will have an implementation which is inherited.
So in that
You know,
case,
their inheritance rules are there. Okay. Fine. Now see, because this is multiple inheritance of methods. Okay. The rules here are like this, something like this. You have inheritance of, this is a class being defined. Okay. It is inheriting from a class. There is a superclass, and it is also inheriting from a interface. Now, if it's the same method, the one from class is the one which will be considered. The class is not overriding the method. Okay, but we have multiple sources. It's from here as well as from here. Same method, but two different implementation of the same method. Right? This is the one which will be used. What will be available is the one which is from a class. So class inheritance of a method from class would be preferred over a default method.
if it is carrying the same name.
Yeah, exactly same methods. Right? Method signature is not overloaded.
But that name should be common, right?
Name and parameter.
Parameters, good.
Return type also, right? Okay, so it's a class from where you need that. That's one thing. Now, if you have from two interfaces, it's not in the class, but it's from two interfaces. Right? Then, empty. If he is not implementing, it's an empty. It's not going to come. Right? Yeah, you have a method M1. Well, let me use this. You have method M1 in interface 1. You have method M1 also in interface 2. and this one is not overriding one. This would not combine. Okay, you are not having it in your class. M1 doesn't exist in the class. The superclass does not have M1. There are two interfaces. They both have their own M1, which is default. One is abstract, one is default. That's okay. The one which is default, that's the implementation I get. Okay, but if both have default, it won't come back. This class can't be done. Okay, therefore you will be forced to override. Now, when you override, you are free to use both the methods. Okay, for example, I may be interested in using from the interface 1. Let me call this as, this is interface 1. Okay, and we have interface 1. So when I want to when I override the method, so we have @override. Okay, method is M1, return type may be void. It has some parameter list. So this is what I am overriding in the class. Okay. Now I understand that whatever is in interface 1, that's the one which I should be using here. Right, so I would like to call that. So what I can do here is I can say interface 1 dot super dot m and use them. Interface 2 dot super dot m. Both are available. You have the implementations available to you. The default which is there is available for implementation. Right? Just like we used to say super dot, right? If you are overriding a method, it says super dot. Then overriding the method, you can't say super because then super would mean super class. Now you have to use interface name dot super in the class. Yeah, it's in class. Right? Yeah. So these are some of the inheritance related and overriding of methods. Right? For default methods. So default methods in interfaces. Right? Default method in interface is on the instance. Right?
So
And here the static method also. Yeah.
prefix are necessary. Interface 1 dot super dot.
Yeah. Interface 1 dot super. If you just say super dot, then it would mean super class.
Can you not import interface 1 dot super dot?
No. The keyword super is not a package or something, right? Import relates to package. Okay. Okay, so that's one, right? Default method, right? That's on Java 8. Okay. Other is
Volatile.
volatile. What's this keyword called? This is about actually Java's memory model. this relates to Java's memory model. Now what this is related to, again, multi-threading, and this is about threads. The memory model related to multi-threading is something like this. You may have, let's say you have some object, okay, there is some object and it has an instance variable of a primitive type. Let's consider primitive type. There is an instance variable of primitive type. You have got multiple threads which are using the same object. And they are working on the same object. Okay, so I have one thread here. This thread is reading the value from the instance variable from the object. Okay, fine. There is one point of time he has read this value. There is another thread who is updating the value again and again. That's it. The job of the other thread is only to update the value in the instance variable. Right? Now, at a particular point of time, let's say this point of time, let me start. Let's say initial value was 0. Okay, initial value was 0. Okay. Thread 1 reads a value. Okay, he reads the value as. Okay. Now this thread is making changes. He is incrementing 1, 2, 3, 4. He is making changes. But at another point of time when he reads the value, maybe by this time, before he reads the value, he has changed it 10 times. Okay, it has become 10. That's according to the second thread. For first thread, when it reads the value again, when it tries to access the value, what do you expect the value should be?
1.
Do you expect it to be 10? No. It can be anything. It can be anything from 0 to 2. There are no guarantees. There are no guarantees about the variable's value which he will have. Unless you declare this variable as volatile. If you declare volatile, then
if it knows it is volatile, then it will wait for something.
it will have that extra code to ensure that yes, the reads, right? Anything which is read is actually something which has been also updated. It's right now. That's the extra code which you can do. Otherwise, it may be something like a cached value for this thread,
So,
which is being used. Yeah.
why do we need volatile keyword? Instead of volatile keyword, they could have done it by default that whenever somebody reads in such scenario, it will be the volatile only situation.
See, it's like normally you don't use some objects with multiple threads. Okay. So only when it's being shared, let the extra code be there.
We can go for the semaphore. I use volatile.
Why use volatile? Okay. Semaphore is your additional overhead. Yeah, it's exactly the same. Right? It's that additional overhead which you will get with the help of.
Same.
Then it's that same. Volatile will ensure that, right? Okay. We had that account class. We have the field called balance, right? Which is getting updated by multiple threads.
Deposits,
When someone is depositing, someone is withdrawing.
timing
Right? So we have not said volatile. If you had said volatile, then also your problem to some extent was already solved. What we had done instead of volatile was we used that same thing. And what we had done was we had used with the synchronized. If you are using synchronized, you won't need volatile. That's all.
Same
But volatile is partial.
Same thing.
Partially soluble.
So volatile and synchronized is same thing.
Not exactly.
When
Synchronized is one at a time. That's
yes, for the locking system. When updating the value, it's not the object.
volatile will ensure the read is again done from the object itself. And it's not the cached read or something.
Synchronized is more preferable than volatile.
If you are using synchronized, you don't need the volatile. Synchronized has its negatives also. Okay. What are the negatives?
Slowdowns.
Okay, performance is one, and possibility of a deadlock
Yeah.
if not properly used. And there's possibility of a deadlock. Okay, because two different threads, they are blocking each other. So that's a negative of synchronized. Fine. So volatile, okay, that could be used with certain variables, which we know that this is some variable which may be used by multiple, and we want them to be we want that this value should be, whosoever is using should get it. What was the other keyword? Asserts. The other keyword is what is assert? Assert is related to what we have something called assertions. And it's not a keyword, we use the term as assertions. Okay. So assertions are nothing but something which we feel is going to be always true, and something which is assumed to be true. Okay. For example, you might have a method to calculate distance. Maybe there's a method called distance. Takes two parameters and returns the value of the distance between. Maybe those are the 2 points and this is distance between points. Okay. Now someone who calls the distance method, and there's someone who is calling the distance method. So he says A equals distance. And passes this. And then I have an assertion here which says I assert A is greater than or equal to 0.
Must distance.
Right? It's a test of my distance method. There's no mistake in distance. Okay. Or if I know I'm actually I'm using a test case. If I know a particular test case value, okay, I could even have, okay, if my this is the point P1, which I have defined as point is 0.3 and this is 0.05. Okay, the distance must be 2. Okay, the distance must be 2. I can say, I can even write assert A equal to 2. It's a test case. You are simply writing the test cases. Fine. Or assert here and say distance this comma this double equals to. You can put your test cases. These are my assertions.
These or these.
So assert followed by boolean, and what you can also do is you can say colon and put a message. Colon and the message is additional part you can have. Colon and message. Right?
So it's something similar like try.
No, it's not right. Let me explain something more. I've just talked about the syntax. Syntax is assert followed by boolean expression. I assert this, right? Now, if you have such a code, if you have written a code which uses assert, okay, you compile and you run this code, right? There's no effect of assert.
Assert will not come into picture in any time.
You may have written any assert, nothing happens.
It will not take
By
into
default.
compile.
By default, nothing happens. Can you compile? That's fine. Okay. You don't have to recompile or anything. But what you do is, when you run your code, you say Java, right? And all those switches, you can put a switch called -EA, enable assertions. Unless you say minus enable assertions, assert are not evaluated. Assertions are not evaluated.
Without this.
By default, assertions are disabled.
So we can
You can even have control over. I want assertions to be enabled for so and so classes, not for everything.
So in that case, that A is equal to distance and the value of parameters are given will carry.
Yes, it will now calculate. So assertion. This is your assertion, right? This is your assertion. So evaluation of this assertion is then done. That Boolean expression is then going to be evaluated.
So see, if I have a class rectangle and I am calculating area L into B. Now I said L into B cannot be negative. I assert that the area is always greater than or equal to 0. Now, if I want to test these assertions, how I will write the value, where I will write the value of L and B. For an example, minus
No,
5.
you don't have to write. So it's like here, even with distance, the same thing. I could have said assert, right? So even in a main method, I can write like this. Any case, in any method which is to be executed, I say assert, and here I am saying distance. Find those 2 points. I want it to be. I assert that this should be 0. This should be.
Okay, so assert only will be.
It's a Boolean expression. That's it.
So assert distance and the parameter default say hard coded parameters can be there.
Yes.
And then we can test it.
So this is your test case.
Test. Okay. So the test case can be included in the
Code
code
itself.
itself. Code
You
itself.
are including it in the code, and if you want them to be tested,
Then
minus
we
enable
have-
assertions.
Yeah.
If you don't say minus enable assertions, then nothing happens.
So I can have my test cases inbuilt into my
Into your code. Put your test cases, include them in your code. Okay. Now what happens if the test case fails?
a message can come if we have written.
If the test case fails, this results in throwing off assertion error. It's a subclass of the error, not of the exception. It's not the Java Language exception, it is a error. So there is a error, there is a class, throwable class called assertion error. It is not under the exception class. Normally you might say, oh, I would like to catch all exceptions. You catch the exception class. Then recollect the hierarchy of throwable, We have throwable, then we have error, and we have exception. Okay, so it's here that we have assertion error. When normally you would catch the exception, so this is not normally going to be found.
So sir, Java.
So one thing here, assert is not used for any kind of a logic. Don't put logic in some logic which you put something which will be executed, no. Which is required to be executed, no. And it's just your kind of test cases.
So after assets, other sentences are also executed after.
Yes.
So
And
Java.
only when you say enable assertions, asserts are evaluated. And if assert is evaluated, if it normally if it is true, it's proceeding. If it is turning out to be false, it is throwing assertion error. And in the constructor of assertion error, okay, if you have specified colon and something, right, that something is going to be taken up as a. If it's a string type, if I'll put it, there are two things which can happen here. It could be either a throwable type. It can be a throwable type, right? In which case it is used as the cause for the assertion error. Right? Any exception, any throwable can have a cause as another throwable. So if it's a throwable type, after colon, it's taken as a cause of the assertion error. Otherwise, whatever you give is converted into a string and used as a message for the assertion error. So it's either a message or the throwable.
So how, what can be the example for throwing string?
First
Here
one,
we have a string. How we can write a throwable thing?
so and say assert. Okay, you have your expression colon new
What is this?
new and create some object of maybe and say I want this is so arithmetic exception. You want to say it's an arithmetic exception, or you might be saying it's a for invalid parameter we use. And there's something called invalid parameters.
I got it.
So it could be any such object. You could have your any throwable object.
I got it.
Okay. But for that, assertions must be anchored. It's just about, oh, I want the test. It can be used for test cases. But nowadays, anyway, there are a lot of unit testing and testing tools are separate. So tests are written separately. Okay. Yeah. What else? And three of those keywords. Now, let's say suffix. Want to take up any other topic from Korea?
So just for a revision, if we declare the string happy for any variable or any
No, it's not for a variable.
It's for a method.
It's for the method or it's for the class.
Okay. So if I declare the string happy class, then I will be able to use double and float. It will compulsory.
You will be using double and float.
Okay. So then
You are still using double and float.
okay.
When we use double, then we have certain precision about the value. Okay. We understand it's a 64-bit, and this 64-bit would be one signed bit. We have the 12 bits, I think, for the exponent, and other bits for the significant. Okay, and it's divided into those terms. So that is still exactly as it is. My only thing here is we have the extension form. It's still the same number of bits, exactly same. Okay, but when it's an extended form, they somehow increase the range. And there is some way by which the range has been increased for the precision. Okay. See, what is normally expected is you will have a normalized form. This has to be in the normalized form. Okay. But with extension, I think they're utilizing some bits in a different way also. So this is exactly same. It's not anything different. Double. You are using double.
And what is the role of big decimal in PPL?
Okay, what is big decimal and big integer? Okay. It's big integer, you can say. It's big integer. Big decimal is big integer with some decimal point, assumed decimal point. So big integer is how many bits you want. You can have as many number of bits as you want. It internally uses a byte array. It goes and keeps a big byte array. Internally it has a byte for big. And to create the object of big integer, you can just use a string and put as many number of digits as you like. There's no limit to that. Any number of digits. You can go for it. Otherwise, for long, 18 digits maximum. You can have 100 digit number. 100 digits, 200 digits. Other. With double and float, the difficulty was, what's the difficulty with double and float? This is 0 on a number line. Okay. Right. Now what happens here is, yes, there is a level of precision. And in case of this, because we are following the IEEE 754, it uses the exponent form. What's happening is, nearer to 0, between 0 and 1, there are basically limited number of values which are available for type float as well as for type double. But between 1 and 2, between 2 to 4, 4 to 8, okay. So there are basically, the number of values are the same. So here, the distance between two representable float is very good. It's like very fine. But as you go away from 0, the distance between two representable float keeps on increasing. It just keeps on increasing. And that change is exponential. So if you are dealing with larger values, I'll explain. Like if I'm using float which is 32 bits, double as 64 bits. I'm just taking example of a float. Right? In float, if you want to represent the value 1, 2, 3, 4, 5, 6, 7, 8, 9. No, you can't. It has 1, 2, 3, 4, 5, 6, 7, 8, 4, and then 7, 9, 2. In between, this number can represent as a float. Float cannot store such. So when you say, okay, you will assign the value, yes, it will be shifting to whatever is nearer. If you talk about those two values.
It is about
So using the actual value. Yeah.
there will be rupees here. So in that case, we have to use big decimal integer.
If you use double, that's okay. In double, for those 10-digit numbers, it's not a problem.
Because it is
But
with carry.
if you go for 18-digit numbers, 15 above 15 digit, you'll face similar problems.
So ideally, we should use big decimal and
Big integer for financial applications or
any
and even scientific.
like if we are adding and subtracting the quantities also, then it should be big decimal.
So one thing, never use float. Never use float. And if at all, double is good.
Big decimals are introduced in Java or
Then big integer, big decimal are there. They are part of the java.math package. There is this package called java.math, and this has the class called big integer and big decimal. These classes are everywhere. It's from 1.17 or 1.0, somewhere right in the beginning. They're not java.lang, that's it. You'll have to use import. Okay. Okay, fine. So, yeah, any other topics? Yes. This is what we have. 23 we may try to revise or
package is always
next one?
package.
Java FD. Okay, so collection framework,
Yes.
right? Okay. Okay. And revise Java 8. Java 8 feature.
Yes.
Number expression number. Okay, so I think I'll introduce the functional interface. Starting with, so what's new in Java 8? Let's look at that. Java 8. What's new in Java 8? So for that, first thing is, what changed is interface. This I think I discussed, right? What's the change in interface?
Default.
Right? Two additions, default and static method. Right? Static methods allowed in interface and default methods. Right? Because static methods allowed in interface, now even with interface we can say public static void.
And we can try to implement this in
So hello world, oh, you have hello interface with public static void. And compile, execute from interface. Main method from interface. So that's the first thing for Java. Second thing they introduced is in interface. Now interfaces have been, there are interfaces which have been categorized as functional interface. What is a functional interface? Okay. So in short, they just used to call it as interface. Functional interface is nothing but SAM. An interface with single abstract method is a functional interface. Any interface which has only one abstract method is a functional interface. Okay, but with a small change. And a small change here is when I say single abstract method, excluding, it has to exclude any method, any public method of the object class. Excluding any public method of the object class. Right? So what I mean by this, okay, excluding. Okay, so I have an interface. So I have a, okay, these are all public interfaces. I have a public interface. Okay, say interface 1. It may be extending from some place. Now if it is extending, it is inheriting any abstract method from the super interface. Right? All abstract methods from super interface are also inherited, and those have to be counted. They may be overridden to be default. See, overriding. Abstract method overridden by an interface also to be default. That's allowed. Okay, so here I am assuming I don't have a super interface. Now I have abstract methods. I am saying, oh, I have an abstract method. So I am not declaring public, by default it would be public. So I have this method which has a return type of object. Right? Name of the method is clone. This is method of the object class. It's declared as abstract, and this is okay. And then I say, well, I also have another method returns void. This is method M1. It may have some parameter and a semicolon. And I might have default methods, I might have static methods. But these are the only two abstract methods. This interface is a functional interface. It has two abstract methods, but I should not count this one because, oh sorry, I will still, because this is not a functional interface. Because this clone method is not a public method, it's a protected method. Sorry. But suppose instead of clone, okay, if I change this method to string, toString. The toString declared as abstract in my interface. This is okay. Interface wise, this is okay. Just assume we have the toString method returns string as an abstract method in the interface, and it has method. This is also abstract. You may have all other kinds of methods, but no other abstract methods. So two abstract methods. Okay. But this is a functional interface because this is a method which is a public method of the object. So I don't count this. So we are looking only at this method as the abstract. The other method anyway is a public method of object class and would be available to anyone who wants to write an implementation. It's going to be inherited from the object class. Okay. So public, don't count the public methods of object class without them. Right? So that's a small caveat. Single abstract method. That is the definition of a function. Okay, definition of a function interface. So we have the concept of function interface. What is a function interface? An interface having a single abstract. And then comes the lambda expression. What is a lambda expression? Lambda expression is nothing but an implementation of the abstract method of a function. Right? I have this interface called interface 1. It's a function interface. And therefore, I can write a lambda expression for interface 1. And for example, I'll say I have a variable of type interface 1. Okay. Let me call the variable name as I1 equals, and here I can have a lambda expression. So lambda expression can be written for anything which is a function. It is nothing but the lambda expression is the implementation of the abstract method. Okay. So what is this abstract? What's the abstract method here? M1. Oh, this M1 has some parameters. Let me say it takes one parameter int x. That's some parameter. Single parameter, or there might be multiple parameters. Right? So when the lambda expression is of the form, when you write a lambda expression, specify the parameter first. So I can say int any variable, it doesn't matter, int a, I could even write a, and then the lambda operator which says greater than, and then a block of statements. This is the implementation of the function. You don't have to say that.
So all
You're not saying override or anything.
lambda expressions are result of functional interface.
They represent an object of a function. They are always objects of the function. The type is function. The type is function. And type will be actually inferred. It will infer the type. It should be possible to infer the type. See, this doesn't mean anything. This alone, standalone, will not mean a lambda expression on a standalone doesn't mean anything. It can't be called as a lambda expression. It should be possible for it to infer the type. It is used in a place where it is known that the type is going to be integer because of the left hand side. I know this is going to be integer. Okay, and therefore it is the implementation of it.
So what could be the real life scenario for making lambda expression that must be interface?
See, this lambda expressions, if you look at them, what are they? They are functions. They are functions. The way I like to look at it is, oh, this is I1 is a reference to a function. I'm able to have function object. This is an object which has a function. This is my function. And I1 is an object, is a reference to an object which has a function. We look at it as functional programming.
So in that case, if I have to calculate the area of rectangle, I can
No, think of interface first, function interface.
function interface. That is what I say.
Yeah.
So if I have
So
only
what is the
one
interface?
See,
Rectangle is interface?
Pardon?
Rectangle is interface?
No.
So first we'll have to think of
Interface which carries only single method,
yeah.
and that is also abstract method.
I'll give one small example which we normally use.
Calculator.
Then I'll give an example. We have a class called current account. Okay. In current account, okay, we have a penalty. For current account,
Yeah.
there is a penalty amount to be calculated. So we'll say, oh, you have an object of penalty. What is penalty? A function. So we create a functional interface called penalty, okay, which has a single abstract method called
Calculate the
compute or calculate and
compute.
compute. See, the name here will not matter much. It's a compute which takes two parameters. What is the
duration,
current balance? Find what is the minimum balance needed. You can find whatever is needed, and it returns value. Okay, so that's why this thing. Now I have a method called set penalty. So this has a variable, type is penalty, the variable name is penalty. Okay. So on the current account object, I am setting a function. This is my penalty calculation function. See, you have to think of cases where you have functions. Penalty is a function and not a fixed value. I'm putting function interface. I'm defining a function interface with one method.
I will declare a current account class, and
Yes.
there will be a penalty is a return type.
Yes.
And
See, now someone says penalty equal to, right? What is this penalty equal to? He is writing a function. And this penalty equal to another function at a different point of time. I can put in a different function, but it's a function, not a fixed value.
For each object providing.
For each current account object, I'm keeping a penalty function. And they may have a different function. Right? They have a negotiation with the bank manager and they negotiate a different. Or bank is giving different schemes. And say, okay, if you use this, you'll have this penalty. In this case, this is the penalty. This is how the penalty calculation will be done. And so there are different functions.
So this kind of inline type, inline function.
This is right function. Yes. And see, now in this function interface, one point was here in this case where we had only a single one. Another point was because it is known this is interface 1, and interface 1 has only single abstract method where the type of the parameter is in. It's actually not necessary to even mention it. You may just use the parameter name alone, A. And if it is a single parameter, you may just write A, not even the brackets necessary. Okay. Again, after the lambda operator, okay, if you have a single statement, no need to put a block, no need to put the braces. If it's a return statement, just put the expression, don't use the keyword return. And that's how lambda expression works.
So in general case, if I am making a simple interest calculator, it can be a lambda expression.
Yeah. Have an interface with one abstract.
Calculate
And wherever that type is needed, yes, you can write that. You are writing the function.
If I make a class for that simple interest calculator, and if I make an interface for this
Interest.
optional interface for interest.
Interest is a function.
Which is more preferred.
Interest is a function.
That
You have something called calculator, but it requires one function. So you have interest
Yes.
as a function interface.
So what is more preferable, making a class or making an interface and a lambda expression?
Yeah, what would be easier? What's the manager?
Maybe
As
class.
a function interface?
Okay.
But interest is a function interface. Interest is a function interface. It has a method compute, right? It has those parameters and returns value.
So but in that case, if I make a class, calculate for a simple interest calculator, and it will have a static method. I just pass on that.
Now this lambda expression which you are writing, right? When you write a lambda expression, okay, but within this expression part, you can use the other local variables. Okay, right? So if there are other things to be used from other places, they are available here.
So that will be an added advantage we can get with research.
But of course, what I'm saying you can only use the local variables which you can use from here. They can only be the ones which are final or effectively final. They have to be final or effectively final. If there's something which is changing, right, which is being changed, it's just a simple variable. No, that can't be used here. Instance variables, they can be used. Class variables, they can be used, but not the local variables. Local variables should be private or iterative data. Then they can be used.
Some method application.
Okay, the concept, there's a concept of a method reference and a constructor reference, which can be used for lambda expressions. So wherever we understand where a lambda expression can be used, wherever we have a function interface. Now, a function interface, coming to the function interface. There are actually a lot of things, a lot of big addition which has been done in Java 8 is the java.util.function package. It uses generics, so you have to look at generics before. Before this, you have to look at generics. Generics per you have to revise generics later. Then we can take this package. What is the Java util function package? Okay. Now, okay, I'll just try to tell you a little about what is method reference. And there's something called method reference. You have a lambda expression. And now I'll assume we have some lambda expression. That means we have some function which takes 3 parameters, let's say ABC. We need not mention the type. And then what we have here, the implementation is A dot. So A is a object and the parameter is some object is of some type. So let's say A is of type class 1. So there's some class called class 1, A is of that type. In that, so we are saying A dot some method M1 where B and C are used as parameters. Okay, so it's nothing but this is a lambda expression which says return A dot M1 and use B and C as a parameter. This is the implementation of the lambda expression. And this is a lambda expression. Now instead of this entire lambda expression is allowed to be written as, if this is the case, what's the case? A is of type class 1. It has a method M1 because A dot M1 is being used, and the idea being the first parameter of my lambda is the one on which method is invoked, where rest of the parameters are the parameters to that method. And I can write the entire thing as class 1 colon colon M1. That's it. Nothing else. No brackets on it.
Okay, so that those two parameters will automatically be this.
So I'm just saying use this method. That's it. I'm just doing use this method.
So method reference will be like
This is a method reference. One example of a method reference.
So this can be written in elaborate manner also. And
You can write this lambda or so this lambda is the same as this is what we call as a method reference.
okay, but instead of lambda expression, I can calculate this in a different manner. Like
If you have a different, if you have something else, then you may not be able to use method reference. So method reference is not always possible. So method reference is possible in those cases where we have a single method invocation. There's nothing else, only method invocation of there's one method being invoked on some object. Or sometimes another case of a method reference.
Sir, but I could not get that where this lambda expression will be written in our Java file. Like
Where the lambda expression is being done.
See,
Okay, I have a set penalty for that penalty thing.
Yes.
So, okay, where a penalty is needed. Okay, so you have penalty as a function interface.
Yes.
Now, I am providing in the current account class, I am providing a method called
Set penalty.
set penalty. What's the parameter? Penalty P. What I have done? This dot penalty equals P. Okay. So on the current account object, set penalty is a method
Yes.
returns value. Right? This is a method of current account class. So if I have a current account, AC is my current account dot set penalty. What do I pass?
Penalty.
Function. Clear? Then we'll continue tomorrow. I think tomorrow we'll look at generic. Right? We'll try to revise generic first. Okay.